Hello friends, so we are going to cover the concept of balanced temperature, and previously in videos and lectures related to basic degree day method, variable degree day method, I have also covered this balanced temperature, but to the very basic of it. In this video I am going to cover it extensively and also give the technical and mathematical formulation for the balance temperature calculations. So my T balance is one of the most important and useful concept while we solve questions. It has a lot of information inside it. So let's jump into it. The beauty of balance temperature is in the building load calculations, like using the steady state building load calculations, we had lot of different loads which are acting, while in the bin method which we studied just some time back in the previous video, what we covered was that for different bins we want to do different calculations, so we have more accurate, more amount of data available for us. But if we want to go on calculating all the loads in each of the bin, then it takes a lot of time. So over there the T balance or the balance temperature calculations helps us. And you may think how. So let's go into some details of it. The basic derivation for balance temperature is right. So we have a summation of Q's or heats which is going to be 0. That's the important part. What does this mean is, I may have different kinds of loads which we have commonly encountered are the conduction load, which also takes into account the infiltration load, then the solar load, then the internal electrical load, the occupants load, and the solar conduction. So solar, and this is totaled to 0. Now we know that the solar loads are heat gaining factors, electrical load is heat gain factor, and occupants lead to heat gain, and this solar also leads to heat factor. This is solar conduction, right? This is one of the factor which also takes into account the infiltration, and this could be positive or negative. These are always positive. These are always going to give us heat gain, while the conduction may give us heat loss or heat gain depending on the outside temperature. If the outside temperature is higher, then we are going to the gain is going to be to the building. If the outside temperature is lower or the internal temperature is higher of the zone or the building, then the building is going to lose heat to the outdoors. So these are all clubbed to single thing, and for this what we are going to do is we are going to open up. So the Q conduction which we know is UA total, I'm extremely sorry, into Ti minus T balance. And these are all clubbed up. Let's say this is all clubbed up to say Q gains, right? So now what I want to do is, using this and this expression UA total Ti minus T out or T balance, these are all the same, and you will realize it just now, minus Q gains, and we'll just open up this. So my Ti minus T out becomes Q gain over UA total, and hence my T out is T balance now, and so that's my expression for T balance. T balance is an outside temperature for a given internal temperature, given indoor temperature for which there is no heating or cooling requirement. That was the statement we gave for balance temperature calculations. So this is the expression for calculating the balance temperature, and now I hope You also know that how the UA infiltration is used or calculated. UA infiltration value is given by rho, V dot and Cp of air, dry air, rho of the air, and V dot is the flow rate of the air which is inside the building, going into the building or going out of the building, right? So the sum of the uses of T-balance, I have already explained the beauty of using T-balance. So now we can just use T-balance. So the beauty is that instead of doing all this summation, we can just simply do this one factor which already takes into account the heat gains, and we can go ahead with the calculations, all other calculations. So if I use T-balance for the calculation, my summation of UA Ti minus T-balance, this Q value takes into account all the heat gains. So we do not need to explicitly calculate all the heat gains separately. Just one expression and all heat gains or all solar loads, all electric occupants, everything is taken account already, right? So we do not need to explicitly calculate all the gains again. And what's the importance, or how is the use of balanced temperature? What it indicates is it takes into account the internal heat gain. So it indicates the amount of internal heat gains in the building, and also we can extensively use this concept of balanced temperature in mean energy calculations, and which includes the degree day method. So degree day method, if you remember, we use a balanced temperature of 65 which was a constant value. Now we can change that value based on the calculation, and we can give which can give us more accurate estimate of the heating or cooling loads. Okay, I hope you have understood it clearly. If you have any problems, do comment on the video and I'll be happy to help you. Thank you.